Since the video is going to be short, I have planned to discuss two sets of things here. One is two quantities, impulse and momentum. These two have the same dimensions. The other one is angular impulse and angular momentum. Like impulse and momentum, angular impulse and angular momentum, they both have the same dimensions. Additionally, Planck's constant is also having the same dimensions. That's what we are going to discuss today now. What is impulse? What is momentum? Suppose you have a mass m and that mass is going forward with velocity v. Then the momentum of this mass is the product of mass and velocity. The physical significance of momentum we will discuss there in the class during second law of motion, etc. Now the dimensions of momentum is actually the product of dimensions of mass and dimensions of velocity. So mass is the fundamental quantity, but velocity is not a fundamental quantity. So velocity is distance by time, so length by time. So the dimensions of momentum is ml t power minus 1. But force, according to Newton's second law, force is defined as the rate of change of momentum. Rate of change of momentum means change in momentum per unit time or the time interval. So when you multiply this, you get force into duration, that is equal to change in momentum. So when a large force F acts for a short duration delta t, then it gives rise to a momentum of delta p. This change in momentum is called impulse, which is referred by the letter J. Then the dimensions of J is actually the dimensions of force into dimensions of time. Dimensions of force, we already know that ml t power minus 2 into time, which is t. Then what are we getting now? ml t power minus 1. These two are the same. So while momentum is a definite quantity, whereas the impulse is nothing but the change in momentum. So momentum is different, impulse is different, which is often called impulse of a force. The impulse of a force is actually the change in momentum. Then the next thing, angular impulse and angular momentum. Let's discuss angular momentum. What is angular momentum? So angular momentum is actually moment of momentum. So moment of momentum is called angular momentum. So usually we say momentum is the impact factor. How much of an impact a body moving translation, a body exhibiting translatory motion, what kind of an effect the impact it can have is called linear momentum. Angular momentum means what kind of an impact a body rotating is called angular momentum. So the angular momentum is moment of momentum. Like moment of force, it is also force into perpendicular distance is moment of force. So here momentum into perpendicular distance is angular momentum. So angular momentum is referred by the letter L. L is equal to actually r cross p. Suppose one object is moving with a momentum p, about this point its impact because of its rotation is this momentum into the perpendicular distance to this point. So r cross p, r is the distance anyway, so its dimensions. So dimensions of angular momentum is dimensions of r, which is length, into dimensions of momentum, which is ml t power minus 1. Then the dimensions of angular momentum is ml square t power minus 1. And what is angular impulse? So the change in linear momentum is called impulse of a force. Change in angular momentum is called angular impulse of torque, because what produces linear motion is force, what produces angular motion is torque. So how force is rate of change of momentum, torque is rate of change of angular momentum. So I'll write like this, delta t delta L by delta t. Then here delta L is called angular impulse, which is the product of torque and the time taken. Then the dimensions of torque, which already know, force multiplied by L, we already know about that. So m L square T power minus 2, which we already discussed. Energy and torque, they both have the same dimensions, into T. So what are we getting now? M L square T power minus 1. So they are all different. You see, angular momentum is this, angular impulse is also that. And you see this one, momentum is ml T power minus 1. The impulse is ml T power minus 1. Angular momentum is ml square T power minus 1, and angular impulse is change in angular momentum. Angular impulse is change in angular momentum. So I'll write this for our thing. Impulse, I'll write it in a different color. So we'll be writing impulse is change in linear momentum, and angular impulse is change in angular momentum. Okay, the next one is Planck's constant. So the dimensions of Planck's constant is derived by the relation this E is equal to h nu, where nu is the frequency. So frequencies is 1 by time period. So the dimensions of frequency is actually T power minus 1, and E, energy. So the energy of a photon is given by this relation. Energy is m L square T power minus 2. Then dimensions of Planck's constant, here the h is called Planck's constant. The Planck's constant is equal to E by nu. E by nu means m L square T power minus 2 by the frequency T power minus 1. When that comes up, m L square T power minus 2 into T power plus 1. So the dimensions of Planck's constant equal to m L square T power minus 1, because minus 2 plus 1 is T power minus 1. So Planck's constant's dimension, momentums, angular momentum's dimension, and angular impulse, I'll write angular impulse, all three have the same dimensions. Then linear momentum and linear impulse. Linear impulse is nothing but impulse of a force, which is referred by the letter J. They are all having these three have the same momentum, these three have the same dimensions, and these two have the same dimensions.